So I'll schematically first translate the information. So we're told that there are 3 direct paths from P to Q, and between Q and S there are 4. 1, 2, 3, 4. So that's S. And then between P and R, 2, 3, 4. That's R. And there's no direct path between P and S, so there's nothing here, P to S. And there are a few direct paths between Q and R, so there's something here and between R and S. So now they give us these possible ways. So you can travel from P to S either via Q, so that's 3 times and 4. So that's going to be a total of 12 ways. Now we're given the total is 62. And what I'm going to do is to call this to be the m number of ways to travel between Q and R, and n number of ways to go from R and S. So if I come back here from P to S either via Q or via R. So if you go through R, that's 4, so that would be 4n. And then or via Q followed by R. So that would be 3. So you're going from P to Q to R and then S. So that's going to be 3 times that 3, then M, then N. So that's our next condition. 3mn plus 4n, that's 12. If you subtract from 62, that gives you 50. So that's our first relationship. The other one is this one. You can travel from Q to R either directly, which is m number of ways. That's what I define that. Or via P or S. So if you go through P, that would be 12 because that's 3 and 4. So number of ways, I should have described that earlier, is if you have 3 ways of going here and 4 ways here, the total number of ways you can take, and that's from fundamental counting principle, would be 12. And then Q, you can go to R from S as well, and that would be 4 times n. So that's my second equation. So this simplifies to 4n plus m is equal to 15. So our constraints are that both n and m are integers. And there are 2 ways to do this, and I kind of just discovered that by accident and not sure what's going to happen in the exam, but we can subtract these 2 equations, subtract this bottom one from the top, because the 4n term would drop out, and you would get this. If you factor m, we get that. So it's product of 2 integers, because these are both integers. 35, what are the different ways I can factor? 5 times 7, or 35 times 1, and we can swap which one is what. So if I start with that one, if m is 5 and 3n minus 1 is 7, well, that doesn't work. So we do the other way. M is 7 and 3n minus 1 is 5. That gives me n equal to 2. So that one works. You'll notice that 35 and 1 also, this combination will now work. So that's our solution. And the question is the number of direct paths between Q and R. They're looking for m, which is 7. The other way to do this would be to eliminate one of the variables, and that's a little bit more work, but what you would do is you take that equation, m is 15 minus 4n, and then you substitute that here, and you'll get a quadratic equation in n. I mean, that's, of course, it's a little bit tedious in this case, but you would be assured that you will get the answer. And I'm going to move all the terms to the other side. And this is a little bit harder to factor, but here the product of 12 and 50, that's 600. And this is going to split into 25 and 24. You'll see that that is indeed 60. So we'll split this, or you can use the quadratic formula. You have the calculator to do that calculation. And then factor 12n and minus 2. And you will see, because n has to be an integer, the only solution is n equal to 2, and then you can plug it back into this one to get m, which will turn out to be 7. So either way, I mean, I think when you're doing this in the exam, it's just kind of, it's just a matter of chance. Maybe you see this, maybe you don't. This, of course, sometimes I'll always go there because I know for sure I'll get something. Here it's a little bit based on kind of observing things, so there's certain uncertainty. So to summarize, the answer is 7.